from Dunedin, but my relatives come from way down by Gore, which is where they really roll their R's. Anyway, I digress. This is called a girder. It would run, it says up there somewhere at the top, it's 6 metres, there it is, 6 metres long. So probably roughly from about here to the other side of that room, over to the other end of the room. Now, if any of you have ever driven your car in to be fixed, into a garage, you would notice that they had those big chains and things hanging down. Okay, if you're a fan of Fast and Furious, if you've ever watched that, they're always hauling them engines up and playing with them and stuff. Yeah. Okay, so what a girder would be put in place in a garage. You'll notice that it's not just a beam, but it's also a channel as well, and at each end it's strengthened with this setup, which means it can take more weight, basically. So you can't just do those chains to an ordinary ceiling like at home, you know, like your living room or something, because it would just still come caving down, because the car engine, well, probably about a tonne, maybe 2 tonnes, it's quite a bit of weight involved. So there's 2 reasons why I'm going over this today. The first one is pretty obvious. You've got beams and, well, actually there isn't a column here. I said there was a column, but we calculate columns the same way we calculate beams. So I'm showing you how to, I guess, schedule steelwork. And it's not straight, it's not it's not that bad. It's reasonably easy, but there are a few steps you need to follow in order to do it, so that when you do it in the assignment, you get full marks. All right? So that's the first reason. The second reason is that little fella there's in the test. So I'll be jiggling with some of the numbers and some of the numbers down here, but the concept that we go through today is the exact concept to working it out for the test. Alright? So the reason for that is that we all know that there's the hey bro effect, or at Unitec, where it's like, hey bro, I haven't done my homework, what did you get for this? And you copy it down and you get 100%. There's actually someone around at Unitec now that's not hey bro anymore, it's called AI. But anyway, there's that way of doing things, and then there's the way where you all have a go at it, and then you have a good argument or conference about it, and everybody learns how to do it. Right? Now that second way works perfectly, because you get good marks in the test and you get good marks because you understand that, and you also get good marks in the assignment. So this is my way of getting the hey bros, because they might be given, shall we say, an answer in the assignment by their friends, but when it comes to sitting down and doing the test, they won't know what's going on. All right? Now, having said all that, there's a handful of you in here today. I'm guaranteed 90% of you are going to understand this, and you're going to end up doing well in the test and this part of the assignment. This is mostly scheduling on the assignment, okay? The ones that aren't here today, well, you know, you're most welcome to sell that video of me talking right now to them.
$100.
Beg your pardon, $100?
Yeah.
No, 200. 100 for me. You all know my favourite colour is red, which is the colour of the $100 note. So without further ado, I'll just explain a couple of the little bits and pieces that are going on there. Up the top, obviously 6 metres long. We'll be using that a little bit further down the line. The next thing is this little if you can see my arrow there, this little thing here looks like a letter C. That's the channel, and those values actually relate back to, if you look at the notes from this morning, there was a T and there was an R1 and so on them. Same with the U-beam, there was a T and a theta, a T and an R, and we don't have anything for the angles. These are the angles here. If you can imagine two rather tall cell phones joined together, that's what an angle would look like. You have got angles on your assignment, so they're not as long as that, and you're given the length of it, whereas here you have to calculate the length, so a little bit different. And lastly, the plate down the bottom. Now, if you haven't realised already, the call up is the old call up. So we're going to convert that into the new one. Yeah. With the angle up here, it says use 7850 kilograms per metre cubed. So in other words, they're pretty much babysitting you for this one. They're saying that for the plate, use 7850 as the metres cubed for the weight. And for the plate, they're actually telling you that it's 14 kilograms per metre for the angles. Now, you're not going to be told that for the assignment. You're going to have to use the 7850 to work out the angle weight. So just digesting that, somewhere in the notes that were handed out today, I think there might have been an example of 7860. I'd like you in the assignment to use 7850, please, for your plates, because my calculations come off 7850. Now, a plate is extremely easy to calculate. It's the width by the length by the height, or the thickness. Gives you the cubic metres, and if you multiply it by 7850, you'll end up with kilograms per metre, or the overall kilograms here. Because we're dealing in kilograms and metres, we should schedule everything in metres. So please don't give me your millimetre schedule in millimetres, or it won't be, you won't be getting it marked. So it needs to be in metres. Sure, you can work it out in millimetres originally, but make sure you give the answer in metres. We actually have all the information we need. I need to do a bit of a chart up there on the board and take you through the wonderful world of scheduling steel.
How can I do it here in this board? The big one.
I'll do a bit of I'll do the actual main schedule here, the answer. But if I'm doing any work, I'll do it over there, so that you can. That's why it's better to film this class, because I tend to go from whiteboard to whiteboard to pointing at something on the monitor. You know, if we just film what I brought up on the screen, it's not so good. I have a way of doing it online which is a little bit better, but I'm not allowed to do that at the moment. We have to teach face to face. Okay. Guess what?
Let's go.
Yeah.
I can't.
I just decided, nah, don't like you. found, check the cable. I don't think it's anything to do with the cable. I think it's just done a reboot. Thank you very much. Okay, so we have the member as it is called up under the new school way of doing it. Unfortunately, I had everything on the screen there, but we'll get around it. It was the number of, it's kind of weird, isn't it? Number of. The length, sorry, I'm going to have to log in again. I better get this in the right order. I'm pretty sure I know what it is, but I don't want to. Is that still shining? Yeah, not sure. Technology, eh? You can see this on your screen. Okay, so the number of, the length, the width, the weight per metre. So we can turn the light perhaps back on again if it width, the weight per metre. The weight per metre cubed. And finally, the total weight. Now off to the side is the thickness. And something that's very important is the total weight down the bottom here. Because when it comes to steel work, like the reinforcing, everything is priced according to the weight. So if you look up Google, you probably see that there is a price at the moment for steel, to buy steel, trade steel. So you can get yourself an approximate idea of the cost of a job by putting all the members down, coming along at the end and working out what the weight is. Now that will vary a little bit. Obviously, if you've got a great big long beam, it's probably cheaper than buying a very small little angle. It's probably a bit of a price markup on the angle. But as a general rule, it's a good guide if a client wants to know approximately what things are going to cost. Depending on your seniority in an engineering consultancy, you often have to do this sort of thing, come up with costs, particularly early on in a job. The client wants to know whether to proceed or not, so these sort of things are important. And you really don't want to be cocking them up by too much, because if you get it wrong, they're always going to come back to you and say, you told me it was only going to be this much and look what it cost. So some of these things are really important as far as winning work goes as well over other companies.
Roger. It's like length, width, weight, and then?
Weight per meter, weight per cubic meter.
Okay.
Meter cubed, then total weight and thickness. So the first member that we've got there that we're going to do is the TFC. I'm calling it a tapered flange because there's a bit of a taper in that side there. This almost looks parallel. That looks tapered. Let's just call it a tapered flange for the sake of the exercise. Normally it's a lot more obvious than that. The tapered one comes in and the parallel is very parallel. But anyway, the old call-up is it's a 381 by 102 by 55 channel. The new call-up is a 381, so you still maintain the first number. TFC 55, yeah. There's one of them running all the way along from one side of the room to the other, and its length is 6 meters. Notice I've put that in meters, not millimeters. There's a point there. The width, we don't worry about the width in terms of this particular schedule. So we just put a dash there. But we do know the weight per meter, which is, okay, I'll put another half mark up for grabs. What's the weight per meter of the TFC?
7850. That's big cube now.
Big one?
14.
14?
Yes.
No. That's the angle. Okay. That is gone. The offer is now off the table. I like this negotiation.
Yeah.
I have good. It's 55.
He said 55.
Who said 55?
Gee.
Did he?
Yeah. It's recorded.
But I thought you said 15 at the same time.
No, I said 15. He said 5.
but it sounded.
We have the video here. We have proof.
Oh well.
Half mark?
Yeah, I guess I what does the rest of the class think?
Yeah.
Yes.
Yeah, thank you guys.
There must be someone that doesn't like him in the class.
That's right.
Okay, you can have your half mark, but you've got to
Thank you.
email me before.
I'm good.
Oh, he's already done it. It was quick.
Yeah, I'm good.
He's doing right now.
So I'll be keeping my eye on you when it comes to marking. Okay. So yeah, 55 is correct, and it comes from the last number there, right? Easy. The next one is a beam, and that's this 533 by 210 by 122 UB, which is they call it a universal beam. Now we call that up by its new name, 533 UB122. There's only one of them. It's 6 meters long. We don't care about the width, but do we know what the weight is?
1, 2, 2.
That's correct, but it's not half. You can't. Yes. Now, for those that don't know this, this is his 5th time in this class. He's finally getting things right. Which is okay. So let's do the multiplications. The multiplications for that are very simple. 1 times 6 times 55 is 330. 0.00. We don't have any thickness of that. 122 times 6 times 1 is 732. I'm just plucking these numbers easily. So, what have we learned? Channels, UBs, and also columns are all scheduled the same way. Very simple. Write the new way of doing it and write the number down. That goes there. You only need to find the length or work the length out, and you're going to get this right. So, in other words, that's the easy part of the assignment. Very easy marks. Now we're going to move on to the angle. No, we're not. We'll do the plate. Okay. Now, the plate is often scheduled wrong by students. It's a little bit. What have we got here? So the plate is 250 by 350 by 25, and the immediate thing that you want to do is go 250 by 350 by 25 over here for the thickness. And that's the quickest way to get that wrong. First of all, the 250 and the 350 are around the wrong way. Because we call them up. The old way was to call it up by 250 by 350 by 25, so we called it up the old way, which was the width by the length. The new way is to call it up as the same thing, 250 by 350 by 25, 250 by 350 by 25, and we go PL. Some people put a P with an L through it like that. I prefer just the letters PL. That needs a 0 in it, or else you're going to get your maths wrong. 250. And so does that. Or does it?
0.02. No, no.
2 zeros, yeah. And that's another way students get it wrong as well. 25 mil thick.
Another half.
So, okay, so watch out for that on the assignment. I'm sure you'll all do it properly. And the weight of steel is 7850 given to you up the top there. Per cubic meters, 7850. So when we multiply this all out, there is 2 plates. There's one at each end. It's not obvious there, but there is one at each end of the girder, okay? So 2 by 0.350 by 0.250 by 7850 by 0.025 gives us 34.34. It was interesting in a couple of semesters ago, there were students they were getting all the numbers wrong here where the decimal point is, and I was getting this number coming out about 4 times bigger than the actual beam, and it was only a couple of little plates on each side. When you look at that sketch, it's obvious the beam goes for 6 meters, so they're going to be the biggest ones, or the heaviest. I've left the angles to last because they take a little bit of explaining. So the angle fits in here. Here's my beam, and the angle fits in here, doesn't it? When you look at the sketch, it fits between the bottom and the top. So we have to figure out that length, and here's where it gets a little bit more complicated. So over here is the UV. We have a number of 21.3 and a smaller number, 12.8. Big T and little t. Anyone watch Play School? You know, here's a house, here's a door, here's windows, 1, 2, 3, 4. And there was Big Ted and Little Ted. I think I'm being PC at the moment. Well, Big Ted is that distance is Big Ted, Big T, and that distance is little t, alright? So, the overall height of this is 533. So it's 533 minus t equals the height. What's t? 21 point. Big T is 21.3. Minus 21.3 equals 490.4. 490.4. So the overall length is 0.49 0.04. There are 4 of them. The width doesn't matter. The weight per metre is 14, because that's given, is it? Up the top there somewhere? See where it says for the plate 14 kilograms per metre? So that's 14. That's not needed, so how do we call up the angle? The angle is called up as 89 by 89 by 11 EA. 89 by 89 by 11 EA, or it can also be 89 by 11 EA. When we multiply that by that by that, we get 27.46. And a total weight of 1123.80. 1123.80 kilograms. There we are. But there is one more thing that the client has asked us to calculate, and that is whether or not the angle sticks out past this point here. So whether or not we have a problem in that it's going to jut out past there for when the chain's coming along. This bit in here. How close is that? Is it going to go over the edge, or is it going to be okay? So it's an 89 angle. So what we want to do is we need to find out if that's 89. The client's asked us if that's 89. Sorry, that's 89. What is that? Question mark. To calculate that, we use little t. So the width is going to be equal to it's not 122, is it? It's the old. I'm pretty sure you've got to use the old call up to find the width. Where are we? It's 210. See here on the old call up, it's 533 by 210 by 122. You don't get that on the new call up. So it's 210. So it's 210 minus T, which is 12.6, I think it is. 12.8. I did that wrong last semester. Oh well, 12.8. And then you've got to divide that by 2, don't you? To get that number. When you take away the 12.8 and divide it by 2, you end up with not that quick. 98.6, that sounds right. 98.6. And we know that that is 89. So therefore that is 98.6. So we can say to the client, no, it's contained within that beam. That is how you schedule steel. Now you have got a problem with the assignment because you've got an angle that looks a bit like that, which your purlin sits on. You've got, and I've given it to you, I've given you 3 members. and one of them is the angle. We know the weight is 7850. And I've given you a CAD drawing of the angle. Any ideas on how we can work out the total weight? That's a cubic metre. That's 7850 per metre cubed. We know the width is 100, isn't it? Has anybody got the assignment? I think it's 100. You having a look at the assignment at the moment? You got that as a PDF? The little sketch, does it tell you what the, I think it's 150 high by 50, is it? 150 by 100.
150 by 100.
150 by 100, and what about the width of it?
201.
Is it 200? Okay. Okay. So how do we calculate that in cubic metres? We've got a CAD drawing of that there. Did you say the area? The big one minus the small one. Now we're talking about this down here. This is the assignment. What did Ingrid teach you about how to find an area or something? The big one here. So you do a square minus that square. I guess that's a long way around it. I think what I would do would be to make that a P line, list it, it gives you the area, times the 200, and you're pretty much there, aren't you? There was a time when the teacher didn't work things out, but there we are. I'm not giving you the answer. You've got to make sure your zeros and your points are all in the right place. But that's how you do your angle. Alright? Everything else you should be able to do off this with the assignment. I don't see so many stunned mullets this time. I think most of you understood most of that, especially the first part. So what I'll be doing in the test is I'll change those members around. There'll be different numbers, different lengths, different calculations, but you'll only get one of those calculations to do in the test with an A, B, C, D sort of thing, or maybe a straight answer. Now, has anybody got anything that they'd like to ask about the assignment at the moment? You've got so many different ways you can start it off. You can start off drawing a plan view like I did in the lecture, and then start drawing the eliminators and the bars. You could just start drawing up the section views if you wanted to do that. You could start with your schedule. I've given an example of a schedule. You can use that example to expand it, start making your own schedule. If you're doing the reinforcing slab, you could do that at the same time as the reinforcing schedule and just make sure each one that equals that. You're going to need a few notes on that drawing, but that's all apart from the actual reinforcing slab. Don't put dimensions on the reinforcing slab. A lot of students make that mistake, and I don't want to see the sectional view on there either. This time it's a little bit of a start from scratch, so you start from a new drawing, and then you put in your title block, and then so on and so on. So you'll be making your layers up as you go along. There's quite a bit of work in it, and there's only about a month to go, so you've got to sort of crack into making some advancements, especially while you've got a tutorial available to you, and you've got me available as well. Next week is just straight class for drawing. There's no actual teaching next week on timber. There's a lecture, but no. So this class is 100% drawing. You guys do the drawing. Right?
You show it or you like class?
Big one?
Do you show anything on the class or React this week or something?
Next week. No, for what? For drawing?
Yeah. You said you only drawing.
It's only you guys drawing. Yeah, so you've got the 2 hours to do your drawings. Yeah, that's right. I would look also at that example drawing that's on AutoCAD. You can open that up off Moodle, and it shows the thickness and everything, and it's the channel one. You know how there's a channel there that I gave you the model answer to on scheduling? Well, that's the drawing that you would do for the channel if you asked to do the plan view. Yeah. Some students have had a look at the channel reinforcing and the example answer. The reason why I gave you that channel and I didn't go over it in class is that it has a lot of things that we don't need for our assignment. It's sort of like me giving you a present to use in the future, because there is all sorts of things in there. We have to change the centres at one stage. We've got they've given a distance to the reinforcing bar, whereas we don't give the distance in the assignment. You've got to work that out. What else is there? Oh, I think there's a limit on how long the bars can be. So there's and working out where the overlap is. There's a lot of things in that drawing that you is extra learning. So don't get too worried if it's a little bit complicated. The one that I did in class should be enough to see you through your assignment. Okay, so it's up to all of you now on what you want to do. And my class student owes me a bit of time now, so she's going to be working flat out for her $100 an hour. Sorry, I'm getting mixed up with the back pocket.